Welcome back. We are continuing our journey on calculus, where we are looking at differentiation using the first principles. So as we have seen on the board, this is what we call the first principle. Given the function f of x or y, f prime of x or dy dx is equal to the limit of this function as h approaches 0. So basically, this is what we call the first principle. This is what we call the first principle. So whenever we are given a function called y or f of x, for us to get its derivative or gradient function or gradient formula, all we need to do is to get f of x plus h and f of x, insert them in the first principle, then we would be able to get f prime of x or dy dx. So we are given this question on the board. It says y is equal to 4x squared minus 1. So remember, y is the same as f of x. So we could easily rewrite this function as f of x is equal to 4x squared minus 1. Okay, so basically, y is our f of x. The f of x that we will need to substitute for f of x in the formula. So where we have f of x in the first principle, we are going to substitute with 4x squared minus 1. So our issue here is just to know how to get f of x plus h. So let's find out how we get f of x plus h. Okay? F of x plus h. Actually, we get f of x plus h from the original function that we are given. Wherever we have x in the original function, we need to substitute with x plus h. Then simplify. And whatever function that we get is the f of x plus h. So let's do that one. So for us to get f of x plus h, we shall use the original function. Where we have x here, we are going to substitute with the x plus h. So let's start now. So we have 4. You can see here we have x. So where we have this x, we are going to put the x plus h. The power 2 will be maintained. The minus 1 will also be maintained. So when we simplify this one, whatever expression that we are going to come up with is the one that we are calling f of x plus h. Okay? So we have f of x plus h is equal to 4. Now, when you expand this one, you are going to get x squared plus 2xh plus h squared. So this inside the brackets here is what this means here. When we have x plus h in bracket square, it means this is we are multiplying this by itself. So when we are multiplying this by itself, we simply say this square plus this times 2, we get here, then this is square is what we get there. Or ordinarily, we simply say x plus h, then we say h by h is x by x is x square, plus x by h is xh, plus this and this is again xh, and this and this is h square. So you can see we have x square plus, you can see 2xh plus h square. Okay, so basically, the expansion of this is basically what we have, then minus 1. Okay, so you can see f of x plus h is equal to, we distribute the 4 everywhere here so that we have 4x squared plus 8xh plus 4h squared minus 1. So basically, the whole lot of this expression is what we are calling f of x plus h, according to the question that we are given. Okay, so where we have f of x plus h in the first principle, we are going to put this one. This is what we are calling f of x plus h. So generally, this is how we get f of x plus h. Okay, let's continue. So now let's see, substitute in the first principle. So we have dy dx is equal to the limit as h approaches 0 of f of x. Okay, so we have everything will be over h, and we have f of x plus h, which is this one. So we simply take this one, 4x squared plus 8xh plus 4h squared minus 1. So basically, this is our f of x plus h. So we continue from there, we say minus f of x. Now, our f of x is the original function, which is this one, 4x squared minus 1. Everything over h. So basically, this is how we are going to do the substitution. Once we do the substitution, we now need to simplify the numerator. So as we simplify the numerator, this is what we are going to get. Dy dx is equal to the limit as h approaches 0 of, okay, so now we get rid of the brackets. So we say 4x squared plus 8xh plus 4h squared minus 1. We remove the brackets. Then even here we remove the brackets. Bearing in mind that we have a negative here, which we are going to distribute everywhere on each one of these terms. So when we say minus 1 times 4x squared, we get minus 4x squared. Minus 1 times minus 1, we get plus 1. Okay, we have to be very careful here so that we don't miss the plus here. Okay, so now everything over h. Okay, now when we are here, we know we are getting our dy dx, which is given by the first principle, the limit of whatever is here as h approaches 0. Okay, so at this point now, we need to look out for like terms. So the like terms that we have, as you can see, we have this like term here. We have this one and this one here. 4x squared and negative 4x squared. So those are like terms. And we also have negative 1 here and plus 1. these are like terms. So you can see 4x squared minus 4x squared will give us a 0. 4x squared minus 4x squared will give us a 0. Similarly, negative 1 plus 1 will also give us a 0. So on the numerator, we are just going to remain with 8h plus 4h squared. So this is what will make our numerator everything over h. Okay, so you can see from here we are going to continue as follows. We are going to factorize the h on the numerator so that we have 8x plus 4h. Everything over h. So you can see at this stage, h is common on the numerator and the denominator. H is on the denominator and the numerator. So again here we can easily divide. We say h into h is 1, h into h is 1. So that we have 8x plus 4h. We are still not done. We continue, we say dy dx is equal to the limit as h approaches 0 of 8x plus 4h. Okay, so now at this point, all we need to do is to evaluate this limit here, then we'll be done. So the way we evaluate this limit here, we are supposed to substitute the limit into h, because we are told as h approaches 0. So wherever we have h here, we put a 0. So we shall say our dy dx is equal to 8x plus 4, 0, which will give us, all this will go to 0, so we shall get 80x. So basically, our dy dx for our question under discussion is 8x. So dy dx is equal to 8x. So this is how we use the first principle when differentiating f of x. Thank you for your attention.